Hello students, welcome to the next lecture on the complex linear transformation. Today I will explain you the concept of the rotation. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel where you can find the playlist of the complex analysis. You can see we have discussed the last lecture on the translations, conformal mapping, Schwarz lemma, residue and many more lecture in this playlist. You can follow it, subscribe my YouTube channel so that when I upload my next video, you will get the notification. Now, what we have discussed so far, we have defined the concept of the complex linear transformation, where I can define as Z is in terms of the x plus iota y, and I call as the Z plane, where W is obtained by the transformation and we call as u plus iota v. And the target of the complex linear transformation is you can transform the Z plane into the W plane by using some transformation. So the transformation, it can be the linear, it may be non-linear or any of them. So I can say this is my U and it is V. Fine. Now this map, if I say the map is from the C to C, this map is said to be the transformation. When you can say that any map is said to be the transformation if you prove the mapping is my 1 1, and second thing is if you prove that the mapping is on 2, then you can say the function or that the function is my transformation. That is basically you have to prove that the function is bijective. Fine. Now as we have seen the in the linear transformation, particular kind of the linear transformations which are discretized as a translation, rotation, dilation and so on. The concept of the translation we already discussed in our last lecture. You can see that the last lecture was on the translation. Now in this lecture we will cover the concept of the rotation. What is the meaning of the rotations? That means if you define the map T of Z, which is e raised to power iota of say gamma into Z, then such map is called as the rotation about the point origin. Fine. Geometrically, what does it mean? That means if you have, this is my xy plane. Fine. If you have the original value Z, this is my Z. Fine. And if you rotate the point Z to say at this point, this is my new point of the T of Z. So I can rotate to this point, then the graph or the angle between them is my gamma. So that is the meaning of the geometrical representation of them. Clearly say if gamma is my positive or the gamma is my negative, depending upon that whether it is my counterclockwise or it is clockwise direction. So that means whenever the gamma is my negative, you can say the rotation moving in the clockwise directions, otherwise it is a counterclockwise. Again, if you look out more clearly, if you have the z plane in the xy, if you can rotate them to the w plane. What is the meaning of that? This is the original value of the z. Fine. If I say this value of the z is moved to the new value at this point, then what does the meaning? This is my rotation and the value of this rotation is my gamma and this value is my t of z. Fine. Or I can say as a w is nothing but my t of z. As I mentioned you, whether it's a gamma is a positive or negative, you can define as a clockwise or anti-clockwise. Another most important thing is whenever you are talking about the rotation transformation, the shape of the graph does not change. What is the meaning of the shape does not change? That means if in the original z plane, the shape is my triangle, then after the transformation in the w plane, the shape is again the triangle. But it is rotated, so some angle, say this angle is my 45 degree. Fine. If the original shape is my circle, then after a transformation, the shape is again a circle. But it can never be happen if the original graph is my triangle. Fine. Then after the transformation, this will be the circle. That can never be happen under the case of the rotation. Fine. Now, how you can think about this concept more with the help of the numerical examples. Now, before that, let me request you, can you like and comment on this video as well? If you are new to my YouTube video, you can subscribe this channel. Now, if I consider that Z is my complex plane, which I define as a Z is R e raised to power iota theta, then what is the value of the T of Z? I can written as this is e raised to power gamma R e raised to power iota theta. So that will be R e raised to power iota gamma plus theta. So what does it mean? What is the modulus of the transformation? Modulus is R, and what is the argument of the translation? Argument is my gamma plus theta. And you are very surprising to see the R is also the modulus of the Z. So that means what you can say from this case, that means the rotation and the original vector has the same magnitude while the argument varies. Fine. And how much it varies, it is increases or decreases depending upon that whether gamma is positive or gamma is negative. Now I will explain you with the help of the several examples. Let's say the first one, your target is to prove whatever the mapping is basically a linear transformation. So what you want to prove? You want to prove that T is my bijective. Fine. So how you can prove that it's a bijective? Your target is to prove T is my 1, 1, T is my on 2. So let's start with firstly, you have to prove T is my on 2. How you can prove that the T is on 2? I can choose any element from the domain. Fine. So let's say I can choose the W belongs to my range or the codomain such that W is equal to T of Z. So can you find the value of the Z? Yes, you can easily find, because the value of the T of Z is e raised to power iota gamma into Z, and clearly say the value of the Z will be e raised to power minus iota into W. Now, because W belongs to the C, also e raised to power minus iota gamma belongs to the C. So that means the product is also belongs to the C, and that Z is my in the domain. Therefore, T is my on. How you can prove the 1, 1? I can take the two elements, say Z1 and Z2 belongs to the domain. Fine. Such that T of Z1 is equal to T of Z2, and then your target is to prove that Z1 is equal to Z2. I can substitute the value. It is e raised to power iota gamma of Z1, which is e raised to power iota gamma of Z2. E raised to power iota gamma will be cancelled. Therefore, Z1 is equal to Z2. Hence, T is my 1, 1. So once the T is on 2, once the T is my 1, 1, this implies T is my linear transform. Look at the second example. Determine the region in the W plane corresponding to the triangular region bounded by the equations in the Z plane. So can you draw the graph in the Z plane? What is given to you? This is my X, this is my Y. Now X is equal to 0. This is the line of the X0. This is the line of Y is equal to 0. X plus Y is equal to 1, and which is bounded by these three equations. Fine. And that is the graph of the Z plane. Then what is your target? Your target is to define the W plane under the transformation of T of Z. Fine. And that is my, what is the graph of this picture? Now it's a very, very simple. You can see my graph is, my transformation is, fine. So that means this is my rotation. Rotation by, what is the angle? Angle is pi by 4. So can you predict the graph? That means this line is rotated by 45 degree. This is the line of 45 degree. The y is equal to 0. is rotated by 45 degree. This is a line, this is rotated by 45 degree. So that could be the expected reason in the W plane after solving this problem. Now how you can solve that? It's a very simple. We can take W is u plus iota v such that W is equal to T of Z. Fine. And what is my Z? Z is x plus iota y. So I can substitute the values. What is my W? W is my T of Z, which is equal to e raised to power iota pi by 4 of Z. I can substitute the value, and my target is to find the value of u and v. What is the e raised to power? It's a cos pi over 4 plus iota sine pi over 4 into x plus iota y. Now you can multiply them, u plus iota v, which is equal to 1 over root 2 plus iota over root 2 into x plus iota y. Now you can equate the real component and imaginary component. Equate the real and the imaginary part. So can you find the value of the u? U is my real. So 1 over 2 into x. Fine. And once you can multiply iota and iota, it is minus y over root 2. Can you find the imaginary components? Imaginary component will be y over root 2 and plus x over root 2. So therefore, you can get as a u and v as my this number. Now, what are the mapping given to you? The mapping is x is equal to 0, y is equal to 0, x plus y is equal to 1. What does it implies whenever x is equal to 0? When x is 0, u will be minus y over root 2 and v is plus y over root 2. What you obtained from them? U is equal to minus v. Fine. Similarly, when y is equal to 0, what is the value of the u? U is my x over root 2 and y is equal to x over root 2. What does it implies? That implies u is equal to v. And x plus y is equal to 1. You can see whenever you have x plus y is equal to 1, your target is v is equal to 1 over root 2. Now you have these three equations. Fine. So can you draw the graph of these three equations? U is equal to minus v. This is the u, this is the v. That is a graph of u is equal to minus v. U is equal to v. U is equal to v like y is equal to x. Fine. And this is the v, and this is the graph of v is equal to 1 by root 2. So can you find the common reason? This is the common reason of the problem. So that means after the transformation of the triangle, again the reason in the W plane is same as triangle. Now look at the second example. Now basically whenever you are trying to solve, there are the two kind of the problem. Find type 1 and type 2. Type 1 is when you have a particular region of the xy plane given. So this problem is my called as a type 1 problem. Type 2 problem is whenever you have the equations is given instead of the Cartesian coordinates, they are given in terms of the equation like of the z minus 2 is equal to 4 or in terms of the argument. This is my type 2. Fine. Again, you can see this is my iota z. Fine. Minus 3. Clearly say I can write this iota in terms of e raised to power iota gamma. Fine. So that means this question is related to the rotations. Now let's start with this. I can start with the W because in the equation number 1, my target is to find the value of the Z. Can you find the value of the Z from this equation? It will be W plus 3 plus iota is equal to iota Z. That implies Z is W plus 3 plus iota divided by iota. I can substitute the value of the Z in the equation number 1. So that implies this condition. Now can you solve them? I can take the LCM. Fine. So it's a W plus 3 plus iota minus 4 iota minus 5 divided by iota, which is equal to pi over 2. Fine. So can you solve them? It is the argument. What is the meaning of the argument? Argument in terms of the complex number is tan inverse y over x. If I say argument of the z, where z is x plus iota y. Fine. Now it is the w. Real component is my minus of 2 minus of 3 iota divided by iota. Fine. Now we all know by using the argument property, it's argument of w minus 3 iota. And how you can write the denominator? It's a minus argument of the iota. How? Because we all know argument of a over b, which is equal to argument of a minus argument of b. Now can you find the argument of the iota? What is the argument of the iota? I can iota, so argument of iota, that is tan inverse. What is the imaginary part? 1. Real part is 0. And what is the 1 over 0? It's the infinity. Infinity means pi over 2. So that number will be my pi over 2. I can take a pi over 2 on the right hand side. This number will be argument of w minus 2 minus 3 iota, which is equal to pi. Fine. So that means, what is the meaning of, if you say the argument of w minus alpha is equal to theta, what does it mean? That means this is the equation of the half line. Fine. This is equation of the half line with the passing is 2 plus 3 iota, whose the end point is 2 plus 3 iota, and making angle is pi with the positive. Why is it positive? Because the angle is my positive. Look at the third examples. Again, you can see in this case, the value of the x is equal to something, y is equal to 0, or x plus y is equal to 4 is not given. So my target is, we can find the value of the z from the equations by taking w is equal to z, substitute in the given equations. Fine. This is the graph of this is the equation of the circle with the center is 2. Fine. Radius is my 3. And once you can use the transformation, that it will again as the circle. So let's start with the finding the value of the w. So it will be w is equal to 2 iota z plus 2 iota. Can you find the value of the z? This is w minus 2 iota divided by 2 iota. I can substitute the value of this z, okay, or I can rationalize them. Fine, I can multiply by iota and divided by iota. So the numerator part will be w iota minus minus plus 2, fine, and minus of 2. I can substitute the value of the z in the given equation of the circle. Now you can LCM them. It is minus iota minus 2 minus 4, which is equal to 6. Fine. So that number will be minus iota minus 6 is equal to 6. I can take a minus iota is a common. So it's a fine, iota minus 6 over minus minus plus, fine. Absolute value of the iota is 1, and it is w minus 6 iota is equal to 6. So what is the meaning of that? W minus 6 iota is equal to 6. Again, this is the equation of the circle with the center is 6 iota and the radius is my 6. And how you can draw the graph? Center is 6 iota, that is the real part is 0. This is my 6 iota and the radius is my 6. This is my radius. Therefore, equation will define as the circle to circle. There is one more method. You can draw it graphically. This is the equation of the z, is the equation of the circle. Now find as a 2 of z. How you can find as a 2z? That means the circle is magnifying. Fine, it's a magnifying. Now you can add them to. What is the meaning of the add them to? That means they are moving the 2 units forward. They are moving the 2 unit forward. And now you can multiply with the iota. And we know iota is my rotation. Fine, rotate through the pi by 2. That means you can rotate them to the 90 degree. Fine. And you can see, if you are interested to solve this problem by graphically, then you can solve this problem by graphically by this method. Okay, look at this another one. Find the region in the W plane. Now you can see this is the region. So firstly, you can draw the region. This is the value of the Z plane, and your target is to convert them into the W plane. Clearly say iota of Z, I can written as this is iota pi over 2. So that means, can you predict the graph? It is rotated by 90 degree. So that means this line, it is rotated by 90 degree. So this is the line of fine. If you think about this line, this blue color line, it is rotated by 90 degree. Fine. Can you predict this line? What will happen if this black color line is rotated by 90 degree? So my intuition is our graph will be look like say this region after the transformation arc. Fine. Now again it's a very simple. I can start with W is equal to T of Z. Fine. I can substitute the value of the W, which is U plus iota V, and Z is equal to X plus iota Y. Now you can find the value of the U and V. Fine, this is X plus iota Y. So can you equate the real and imaginary component? U will be my minus of Y and V will be my X. Fine. Now corresponding the region, X is equal to 0, Y is equal to 0, X plus Y is equal to 1. When X is equal to 0, clearly say V is equal to 0. When Y is equal to 0, clearly say U is equal to 0. When X plus Y is equal to 1, what will happen? So when it will be X plus Y. So X plus Y will be happen only when you subtract them. V minus U is equal to 1. Fine. V minus U is equal to 1. Fine. Now can you draw the graph? V is equal to 0. This is the line of the V is equal to 0. U is equal to 0. And V minus U is equal to 1. So that is a common portion which is defined corresponding to the region. And again you can see the triangular region map to the triangular region. Clear? Okay, these few questions are exercise for you. You can solve each of the questions and let me know your answer in the comment box so that we can see whether you have understand this lecture or not. We will see the next lecture very soon on the next property of the linear transformations. Till then, you can follow my YouTube channel, subscribe it, share this video with your friends. Thank you very much, students. Happy learning always.